All right, today we're going to go over the unit of measurements that we would normally use in statics. And then we're going to go over their dimensions, what you would put down as you write them. You want to put your SI units and also our customary units, and what we usually use for those as well. So what we're going to first do is start out with the quantities. And the quantities, for the quantity that we want to look at first is mass. That is a quantitative unit. And again, if you don't remember, the units answers the question, what is measured? In this question, mass is measured. There's also another quantity, and that is length. So we have now mass, we have length, and we also have time. These are what's known as the primary units. Primary units of measurement in Newtonian physics. For our purposes, this is all the kind of units, every unit that we come in contact with in statics is derived from these three primary units. Now there's also derived units, which we'll get into right now. So we have derived units. We're going to mostly consider and 99 to 95% of what we do in physics, in statics, is these units of measurements. So we have mass, length, and time, primary units. We also have derived, which is it's a force. That is known as a vector unit, or vector. And then we also have moments. So we're going to use moments. We're going to use these things, and these are the derived units. So these derived units make up a combination of the primary units. So again, the primary units, there's only three of them in Newtonian physics. That's mass, length, and time. So the way we would write that in statics is we would say m is for mass. That's how we would describe it as we were writing our equations. Length, sometimes it's L. Most of the time it's L. In this book, sometimes it's a lowercase l. Sometimes I've seen it capital M, but usually the time it's a lowercase m. And time usually represents T in this book, but I've also seen a capital T, not to get confused with temperature though. So again, this is T. Lowercase, we're going to use the lowercase m. We're going to use the uppercase or lowercase l and the lowercase t, usually for statics. The ones for force, we would see an F, and it also sometimes an R, and R stands for resultant. For the moments, we would use, most of the time, we would say it's a capital. And sometimes you would see a tau for torque, but not so much in this case. We don't talk about torque. We talk about moments. We talk about bending moments in this. So if we continue down the road, if we go back up to what our mass is, the SI unit that we would describe this object having a mass of some sort of unit. In the SI, it would be kg, and that stands for kilogram. In the length, in the SI, we would go with meter. Now if you notice, it's already starting to get confused because mass is in a dimensional, which deals with this m, deals with this mass. This m is the SI unit of length. So it's very easy to get confused. It's very paramount that you organize your work accordingly. And so I just wanted to state that out, because if you don't, you can get really messed up. Time is T, and the unit is S. So these are the custom units that we would use when using the SI. So we have kg for kilograms, and that's a quantity of mass. We have the unit of meter, which is a dimension of length, which is a quantity, or dimension of L, the quantity length. Then we have the quantity time with the dimension of dimensional lowercase t usually, and a unit of S. Now for the force, we would say that it's N, and that stands for Newton, and we can thank Newton for all of Newtonian physics. And that the dimension is usually dictated by a capital F or capital R. A torque, we would say, has an SI unit of Nm, or sometimes you'll see without that dash, and that stands for Newton meters. So those are the units of SI measurements. Now, there's all of these ways that you can organize this, but if you organize it well, and you take caution in using these and really methodically go over, it'll be very helpful in your statics and beyond in engineering in general. So if we continue on with our mass, our US customary, sometimes you'll see a slug, not too much in your book, but you'll also see an LB and M, and that stands for pound mass, which is different than pound force, which is a force. We'll get into that later. So further on down, we have the length we'll see as a foot or an inch. Sometimes you'll actually see some others, but foot and inch for the US customary for the quantity length. And time is still in seconds, but you would write it SEC is a standard way to write seconds for a dimensional T and the quantity of time. Force, you would say pound F or LBF, and that's lowercase l, lowercase b, and this lowercase subscript f, and this stands for pound force. Moments, you would have also a pound force, but then you might have an inch, so a pound force inch, or inch pound, sometimes it's referred to, and then you would also have a pound force sometimes as a foot. So it's a foot pound or pound foot, pound force foot, sometimes you would write. But notice the difference here, and we'll go into this as you step through statics, but you have this pound mass and this pound force. So you're kind of getting into undressing and opening the hood of a hood to see what's beneath. So a pound doesn't represent a pound anymore. You have to get more precise than that. In this case, you want to represent a pound mass, LBM, which has a quantity of mass, or a pound force, which actually has a quantity of force. Don't confuse them, they are different. When it's asking for a force, here are the units you use. You would use a Newton or a pound force. If you were asking for a mass, you would use a kilogram, a slug, or pound mass. Normally a slug's not in this course, but that slug you might hit in thermo and others. But they do get confused often. Please don't confuse them. By now you should understand the differences. I've seen over and over again when it's asking for a force, students want to give me the units in kilograms, which is a quantity of mass, not a force, and it is completely incorrect if you do that. So please don't make that mistake. Until next time, I will talk to you later.